All right, thank you, Gretchen. I'm Adrian Giovenco, CEO and co-founder of InSpire Transpiration Solutions. Thank you for the opportunity to share some information with you guys today. Let's jump in on the next slide. We learned earlier from Corinne that light plus CO2 plus water equals the sugar and oxygen that we're looking for. The plants need to make sugar because this is plant food. And if you can't do this effectively, plants suffer and your outcomes will suffer in the facility. So when the people who work with plants tell us that there are 9 cardinal parameters, we must remember that CO2 and light are only 2 of the 9 important things for plant growth and vitality. As providers of HVACD systems, we designed equipment knowing that we had direct control over 4 of the 9 parameters, the ones we highlighted in the circle on the left side of the slide, but indirectly, we affect the 4 parameters in the root zone. And even more importantly, if you want to take advantage of the investment that you've made in your lights and the full spectrum of photons they provide, you ideally want to have the healthiest plants to do so. Now, all of this comes down to the environment. We take it so seriously because we recognize that environmental control is cultural control. And the backbone of an IPM, or integrated pest management plan, is environmental control. You know, our team has a mantra, and that is, you must control the culture or the culture will control you. And managing your environment correctly will prevent a whole host of more costly interventions. And we just heard a little bit from Chris about the importance of the biosecurity mindset. We can talk about that a little bit more and dig deeper into it, but it's something that's so important. In this case, you can truly say that an ounce of prevention is worth a pound of cure, or in this case, cured bud. Let's move to the next slide and discuss the importance of temperature. It is significant because the actual plant cells will thrive in a narrow band of temperature, and outside that, they'll assimilate less and less of that precious CO2 that they need to drive the sugar making process. But keep in mind that leaf temperature and room temperature are sometimes 2 very different things. So how do growers balance the room environment to control the leaf temperature? Let's move to the next slide and take a look. So most sophisticated growers will use a VPD chart, which is the chart on the left. Let's start with some definitions. A plant will move water through the root system, up the stem, into the leaves, and out of tiny pores on the leaves. The pores are called stomata. This process is called transpiration and is driven by the fact that just inside of the leaves, on the other side of the stomata, are saturated wet pockets of air. The high humidity inside the plant creates a pressure with the external environment, which is at a lower humidity. And this pressure is called the vapor pressure differential, or vapor pressure difference, or vapor pressure deficit or differential, all abbreviated as VPD. In this case, difference, differential, deficit mean the same thing when you hear that. We can take a leaf at a specific temperature and set of temperature and humidity conditions and generate the VPD metric most typically calculated in pascals to measure that pressure. And now a sophisticated grower uses this particular chart to try to maintain a temperature and humidity most conducive to the stage of life that the plant is in. As a mechanical engineer, we use a similar tool called the psychrometric chart, which is this chart on the right, to design an environment that delivers the VPD to the grower. That is, we deliver an environment that allows the plant to have a VPD that is suitable for its appropriate stage of growth. And in doing so, delivers maximum vitality and yield. Now take note that the axes on both charts have temperature and relative humidity, which allow for these charts to be used together in conjunction. Now, moving from the theoretical, this chart can often be misapplied by people who don't understand that the VPD chart is not a static diagram. In fact, it starts by knowing that the temperature of the leaf relative to the room around it. And this is most directly impacted by the type of lighting that serves the plant. Let's move to the next slide and look at this in practice. This VPD chart is drawn on the condition whereby the room temperature and the leaf temperature are the same. This is usually indicative of a room at night where there are no lights shining on the plants. Let's move to the next slide. And this is a VPD chart showing optimal conditions for a plant when it is exposed to LED lights. Take note that in this case, the leaf temperature is cooler than the room temperature, or in practice with the HVACD systems, the room temperature is held on the warmer side. Let's move to the next slide and look at a VPD chart showing optimal conditions for a plant when it is exposed to HID lights. Here, the leaf temperature is warmer than the room temperature, or in practice with the HVACD system, the room temperature is held on the cooler side. Now, can you see the difference in how the chart is redrawn each time we've gone through that exercise between those three different charts? The real point to drive home here, hang on one sec. The real point to drive home here is that VPD is a moving target in any room, and it really requires a deeper understanding than what a downloaded VPD chart off the internet and taking that and treating it like gospel would allow you to do. Now, thankfully, growers are coming around to understanding this and can use our horticulture-specific environmental control systems to bring dynamic VPD to their rooms. Let's move to the next slide and talk about the significance of data, metrics, and KPIs. It's so important to be able to take advantage of data and learn from data. But if you don't have a funnel and a means of taking that data, turning it into metrics, and ultimately KPIs for your business to be benchmarked on and be able to take actionable corrections or direction from that data, what was then that purpose of gathering that data, right? So benchmarking is a key function in figuring out where you start from and where you're at, and then you can use different types of these metrics and KPIs, whether it's grams per watt, dollars per gram, operating cost per pound, condensate capture over total water, things like this from a high-level cultivator perspective and business owner perspective. On the lighting side, we can talk about micromoles per joule. For us on the HVACD side, we talk about pounds per hour of moisture removal per kW of electricity that it costs to remove that moisture. And it's such a more impactful metric than tons of cooling type metric. Let's move on to the next slide and talk about some HVAC design considerations. This is as Chris from Livewell documented. I mean, it's come up a number of times through the panel today. This is a moisture removal challenge, not an air conditioning challenge. And knowing that and knowing that it is really based upon understanding your actual daily watering rates is such a key component. And we'll talk a little bit about sizing in a second. Room conditions are key to that because different, as we just talked about, different types of lighting systems require different room conditions. And then those room conditions have either a positive or negative effect, derating or increasing the capacity of any given HVAC system based upon what those room conditions are and the amount of moisture that you wish to remove. Airflow considerations have just been touched on significantly in the last couple, especially with Chris Ulig, which is great. Just consistent, clean, trying to remove microclimates. Airflow is really one of those things that can significantly positively impact your facility with not a whole lot else to it if you're having big challenges. And I'm really glad that he talked about biosecurity. That's of course, all of these topics are things we could have much deeper dives on. So just to quickly flash up for you, what we use as a basis of figuring out the pounds per hour of moisture removal to size HVAC equipment. So pounds per hour is truly the daily watering rate times the percentage of moisture removed during the day divided by the number of photoperiod on hours, and then converting from gallons to pounds of water. And this is just a graph that'll give you an example of a particular room. We go to the next slide. This is really important. We're advocates for growers to know and understand this equation and be able to be an active participant in the design of their systems. But with any rule or equation really comes nuances and exceptions to the rules, and understanding that there's different rooms, different veg rooms versus flower rooms versus mother rooms. Also different proportion, we'll have different proportions, as well as different crops will have different proportions. It's very, very important to understand that. Let's recap on the last slide and give you a few nuggets to take away to the Q&A section. Cultural control is the foundation of success. We really are big believers in that. And the environmental control via the HVACD system, D for dehumidification, is key to any IPM strategy. The third bullet here of different HVACD systems, system types, we could go into another multi-minute, hour conversation about all the different types of systems. It's mostly important to understand that there's many different types of HVAC systems out there, and it's really important to be able to evaluate the limitations and risk of different types of systems, be able to look at different types of energy saving features, work that in conjunction with your utility early and often, as mentioned earlier, and then be able to balance that with CapEx, OpEx, and cash flow in your speed to market plan. I'll just leave you with, we advocate for choosing your partners with care, and we always want to say treat those plants with respect and have fun. Thank you.